guys? Let's see. Yeah, mathematics, the beautiful language of nature. It's the beast. It's the beauty. Some people get afraid of it. Some people find it very easy. But most people don't like it. They hate it. And it's unfortunate because it is really one of the most important language that we can learn. It is a condensed language. It makes you able to understand all the tricks that nature does, or it means very many tricks that nature does. It's like poetry. It condenses and reduces the worlds, and that obstructs the essence of what you're looking at, right? It's the same with numbers and the math. When you describe something, when you look at something, you get rid of all the number that doesn't mean anything and look at the one that does. Okay, I think I have another slide, don't I, Abdullah? Here you go. So my take on this is from a wave point of view, okay? Why? Well, there is two reasons. First of all, I spent all of my adult life doing waves, research and stuff. And also, maybe the most important one is that waves is almost involved in everything you know about and everything you don't know about. You may take light, the light that goes into the black hole in your eye, up in your brain, and it vibrates. It's waves. It's electromagnetic waves. The chemical reaction in your brain is wave-like behavior. Sound. I speak here. The air gets in vibration. It hits your ear. Transfer into your brain to interpret the stuff that I'm saying. Hopefully you like it. I don't know. At the same time, you get light through the black hole of your eye, and you make a mix of it. The spin of black holes. Two black holes emerge, start spinning, and gives us gravitational fields that we can measure as some sort of waves. Pulsation of stars. The star pulsates due to the heat and chemical reaction inside of it. And it sends out light and heat. Traffic jam. Imagine all the cars at a stop, lined up, standing still, and all of a sudden there is green light. And you standing aside, looking at all this, the line. And then you see the first car moving away, the second car moving away, the third car, and so on. Well, you see, if you look at the motion, you see a wave going back in the queue. Why do I talk about all this? The formula you see on the screen is a formula called Euler's formula. It was discovered 250 years ago, approximately, 250 years ago. It contains iconic numbers. And it is so tightly related to waves. And waves is so tightly related to your life. Either you know it or don't know it. So what have we? We have a letter E. It is not just a letter. It is a letter E. You can find this letter when you look into different type of processes. For instance, when you look at economic growth, that was actually perhaps the first time they discovered this letter E. It's some letter E means a number between 2 and 3. It is a very precise number. You have it in process that involves heat. You boil water, you take it off You let it cool down. When it cools down, it decays. The water temperature decays, is reduced, and the E is involved in that reaction. We call that the Euler's number, this number. And then we have the I, which is a crazy number, imaginary number. If you take 2I and you pronounce 2I, you will get I. If you take 2I, multiply the two guys, you will get -1. And that's the type of I we're talking about here. So it's a very abstract number space that we are dealing with, right? Imagine yourself that you will be able to go into this, you are living in a real world. Okay, let's stop there, okay? Now, I want you to imagine yourself that you're walking into a room, imaginary room. In that room, you can do anything. You can go from one corner to another corner. You can move in any direction you want. You will never lose energy. You will never gain energy, right? That is the type of crazy room we are talking about. But it is extremely important. Pi, you've seen pi. All of you guys seen pi. It's the relation between the diameter and the circumference of the circle. If I put all this together, I will have something that describes a motion that goes in circles. If you look at my finger, it describes how this guy is moving. This finger is moving, a circle like that. And the fact that it does that has a tremendous impact for us to describe different type of scientific phenomena. So it is one of the most iconic formulas in mathematics that you see right now. And this is the only slide that I'm going to show you. So if you don't remember anything from math, remember this. We can generalize this further. There is a pi. Let's get rid of the pi, let's put in a t, as for time. And then we'll let t go, as it always does. What we have is what I said to you, this thing going round and around and around. So what's the deal? Why is this so important? The important thing is it describes a wave. A wave is something that repeats itself. Going around in a circle, you can imagine you're repeating the move over and over again. With this simple formula, you can describe almost anything that you may think of. All the things that I lined up in the very beginning of this speech, you can describe by this formula or modified version of this formula, right? Everything moves. It vibrates. If it does, we can describe it in terms of waves. Sometimes these waves are abstract. Sometimes they are real, right? But we can always go back to this. When I speak, I said before here, when I speak, I produce sound, and the sound moves the air particles in the air. It hits your eardrum. The signal is converted to electrical signal in your brain. You interpret what I say, and so on. This whole process can be described as acoustic waves and electromagnetic waves. Let's see. Okay. If I whistle, I would make a pure tone, fairly pure. A pure tone, one pure tone, like this. Yeah, good. Yeah, I will get back to that, okay. Hang on. One pure tone means one E-I pi, okay? Now, if you all guys here starts whistling with different tone, I will see as many EI pi as you guys are here in this room. When I talk, my words are combined of many of these Eulers, of these functions. If I clap my hand like this, if I clap my hand, there will be billions or trillions of those that I have to combine in order to describe that. But the key thing is, I can do that. Okay, so let's leave this for a while. If I generalize it, I've been talking of one formula here only. And I've said that most of the things that we are surrounded with can be described as waves. The impact of math on our daily life is tremendous. And maybe you don't think about it so often. But I want you to imagine that you didn't have any cell phone. You didn't have any computer. You didn't have any internet. You didn't have any car. You weren't able to fly from here to United States, UK, wherever you go. You weren't able to listen to music, modern music, with amplifiers. Modern house. Okay, you can live in an old house, but the modern house today. Advanced medical care. All these things that I mentioned here, and millions of others, forget about it if it weren't for using the math. Think about that. So without the mathematics that we know today, you weren't able to listen to what I'm saying here now, and have all these things that I mentioned. So we use the math to understand the laws of nature, and we apply the math to design things to improve our lives. That's what we do all the time. So it's extremely important. Also, it's a language like no other language we invented. I said in the very beginning here, it's like poetry. It is like poetry. You condense things. It would reduce of things that we don't need in the description of a process. But there is a major difference. It has its own logic. And therefore, and for no other reason, it may be explored and developed to obtain new abstract mathematical concepts. And we don't have a clue if we're going to be able to use them. We don't care. The math will lead us. It will give us some new insight to mathematics, but maybe we're not able to use everything that we learn in terms of mathematics. How abstract is this formula? Can everyone see this formula? Yeah, you can see the letters, but can you see it in nature? Can you see it in nature? Yes, you can. Everyone here can see it in nature. You have to imagine yourself. You have to imagine yourself standing on a beach. It could be a sunny day, it could be a cold day, winter day, doesn't matter. You're standing near at a beach, looking at the surface of a wave. Water waves. You can see the water is moving up and down like this. And then what you do is you focus on some line, average line, that the water oscillates like this. Again. And you will see the water level going up and down. Every second time the water crosses this line that I'm talking about here, you see this equation in real life. If the water is messy, if the waves are not that clean and pure, maybe you will see 2 or 3 or 4 combined. if instead of the pi here, you put in the time t and let the t go, then you can see the whole complete waterway going to propagating towards the beach. So this was really my take on the math, and I hope you see that this only beautiful formula that I showed here, I bet you will remember it, but the formula here really is so extremely useful in terms of describing whatever you may think of in terms of science, economics, what have you. It even may describe when you wake up in the morning, you go up, you eat breakfast, you go to school, you go home, you do your homework, you go to bed, you wake up, and so on, and so on. It goes round and round. It can be described by this. Okay, thank you.